Hello there, and welcome to Science for Sleep, where curiosity stretches out like a blanket and science tiptoes softly into the quiet hours. This evening's exploration may seem, at first glance, like an unlikely lullaby. It's about something immense, something terrible, and yet something awe-inspiring in its scale and complexity. Tonight we're talking about the nuclear bomb, not with fear, not with alarm, but with wonder and a whisper of caution. Because beneath the destruction lies a story of invisible forces, of tiny particles with enormous potential, and of human beings who learned how to crack open the very heart of the atom. It's a strange kind of fire we've made. Not the warmth of a candle or the flicker of a campfire, but a sun unleashed for seconds, maybe less, right here on Earth. Have you ever looked up at the night sky and wondered what it would be like to hold a star in your hand? What it might take to light it? What happens when it burns too fast? And as you're listening, I wonder, where are you tonight? What does the sky look like above you? Is it full of stars? Or clouds? Or maybe just the soft flicker of a lamp by your bedside? If you find comfort in slow science and gentle curiosity, I'd be so grateful if you'd tap like, maybe subscribe, or share this little corner of calm with someone else who needs it. It helps us keep these stories softly spinning in the night. So now, if you're ready, if your thoughts are slowing and your pillow has found just the right shape, let's begin. Because within the silence of atoms lies the thunder of creation. And somewhere between sparks and shadows, sleep and sunlight, is the story of why a nuclear bomb is so unimaginably powerful. There's something strange about the way we respond to the idea of a nuclear bomb. It doesn't feel quite real, does it? Not in the way a thunderstorm feels real, or a sharp corner of a table, or the slow ache of a memory. A nuclear bomb is different. It lives in a part of the imagination that's both too large and too distant to touch. Sometimes it's a mushroom cloud in a history book, flattened buildings on old black and white film reels. Sometimes it's just a word, nuclear, that makes your breath catch for a moment before you tuck it quietly back onto the shelf labelled too much. But every now and then it surfaces, a headline, a siren test, a story someone tells softly with a kind of disbelief in their voice, and suddenly the air feels thinner. Like the very idea of a nuclear blast steals oxygen from the room. But even then, it's abstract. Because here's the thing. The human brain isn't built to grasp extremes. We're great with campfires, teaspoons, 10-minute waits. We're good at counting up to 5, maybe 10. We know what it feels like to stub a toe or burn a finger on hot tea. We know what loss feels like in single doses. But scale is where our minds get fuzzy. What does 1,000,000 degrees even feel like? What does flattened within a radius really mean when you've never stood in a radius before? What does it mean to destroy a city in a blink? Not in the movies, but on a quiet morning when people were eating breakfast, going to school, buttoning shirts. Our minds recoil not because they're weak, but because they're protective. Because some truths are too vast, too luminous, too sharp-edged to hold directly, and so we flinch inward, not out of cowardice but out of care. And yet, the feeling lingers. Even if we don't understand the math, the science, or the physics, we understand the silence that follows. We feel it in our bones, even if we don't have the words. There's something primal about the nuclear bomb, not just because it's dangerous, lots of things are, but because it breaks the rules we thought were unbreakable. It takes the invisible, the intangible, the molecular, and turns it into thunder. It turns mass, the solidness of a thing, into light and flame and pressure and silence. That idea, that something can vanish and become energy, is magical. It feels like a story from myth, alchemy, a god's trick, a word spoken and the world shakes. And maybe that's why we whisper around it. Because part of us understands, instinctively, that this is power not meant for casual use. It's too large for that. Too sacred in its own terrible way, like watching lightning strike and knowing, even from a distance, that it could have been you. You might have noticed that when nuclear weapons are discussed, in films, in politics, in textbooks, the language shifts. It becomes clinical, precision, yield, deterrence, mutually assured destruction, big ideas with tidy names, and yet no number, not kilotons, not megatons, quite captures the feeling of heat on skin that used to be a shadow, of silence in a place where thousands were laughing a moment ago, of the way light can blind you even if your eyes are closed. This too is psychological. We buffer, we sanitize, we step back from the edge and wrap horror in charts so we don't have to look directly at it. Because there's something in the nuclear that asks us not just what science can do, but what humans should do. And those questions don't always sleep well. Even the word itself, nuclear, hums with contradiction. It means energy, progress, modernity. But it also means warning sirens, bunkers, radiation, shadows etched into concrete. It's science and silence, power and absence, a future and the end of it. And what's more unsettling, it's small. A nuclear weapon isn't an ancient dragon or an enormous storm. It's tiny things, atoms, protons, neutrons, rearranged. It's subatomic decisions made inside dense cores, where no one can see. It's science with a whisper, not a roar. Which might be why it feels so uncanny, because in our ordinary lives we don't expect the universe to rearrange itself. We expect a candle to burn from wax. We expect a car to run on gasoline. We expect energy to come with effort. A fire built from wood, a sun born from gravity. But nuclear energy doesn't follow those same scripts. Instead, it breaks a rule so fundamental we barely knew it was a rule. The idea that mass stays mass. And it does this with a kind of eerie elegance. Not an explosion made from gasoline and chaos, but from balanced sheets of energy. From Einstein's quiet equation, E mc², which tells us gently that matter and energy are two faces of the same mystery. So the bomb doesn't explode in the way we imagine explosions. It unfolds, it becomes, it transforms. It doesn't just burn, it converts. And in that conversion, something ancient happens. Light, pressure, heat, silence. And this changes how we feel about the world, even if we don't know the physics. Even if we forget the dates or the treaties or the Cold Wars or the hot summers, somewhere, deep inside, we remember that this exists. That humans built a sun and dropped it. That we opened something we cannot close. And that knowledge lives quietly in us, in the same part of the brain that flinches at cliffs or counts lightning after thunder. Because once you know what atoms can do, you can't unknow it. And maybe that's why nuclear weapons live more in dreams than in diagrams. They haunt the edges of our imagination, not because we don't understand them, but because we do. We understand what it means to be undone by something we made. To build a thing and realise too late that it has outgrown us, that the fire doesn't know who lit it. We understand too the way humans seek control. The bomb, in many ways, is a strange kind of wish. The wish to hold power so great it prevents its own use. The idea that if something is terrifying enough, it will keep us safe by standing quietly in the corner. But that safety, if it is safety, comes with weight. There are people alive today who grew up under that shadow, who learned how to duck under desks in case of a flash, who lived with maps of fallout zones and air raid sirens as lullabies. And even now, in quieter decades, the presence remains. Like a locked box in the basement, like a fire alarm with no fire, just waiting. And this waiting, this quiet vigilance, affects how we think. It shapes the stories we tell. It sharpens the edges of nightmares. It adds a layer of tension to headlines that might otherwise be just political. Because when the power exists to destroy everything, every small thing matters more. Every handshake, every speech, every satellite photo. And while most of us live our days without thinking about nuclear weapons, we cook, we drive, we worry about emails, there is still, beneath it all, a background hum. Like a low-frequency sound only part of you hears. It's the feeling of knowing the clock exists even if no one's watching it. But perhaps the strangest psychological truth is this. We're both horrified by the bomb and fascinated by it. Like moths to flame, like children watching a magician. We want to look away, and yet we lean closer. We imagine it, we fictionalize it, we rehearse it. Not because we want it, but because we're trying to understand it, to fit it into our world, to shrink it down to something nameable. Because if we can name a thing, maybe we can hold it. And if we can hold it, maybe it won't slip through our fingers. And so we write about it, we debate it, we dream about it, or through it. Sometimes gently, sometimes not. Because even the softest minds can touch dark questions, if they're given time, if they're allowed to hold the shadow without flinching. And that's why, here, in this quiet space between science and sleep, we talk about these things not to provoke, but to ponder, not to fear, but to feel. Because the story of the nuclear bomb is not just about technology. It's not even just about history. It's about us, our reach, our restraint, our wonder, our warning. It's about how something so small, an atom, a thought, a moment, can change everything. And how even now the quiet ticking in the back of the mind reminds us what we're capable of, not just in destruction, but in awe, and maybe, just maybe, in wisdom. Long before the world split the atom, long before uranium was weighed or neutron cross-sections measured, humanity already knew the shape of unimaginable power. We saw it in lightning, in volcanoes, in wildfire and plague and the sudden rage of the ocean, and we named it gods, spirits, judgment, wrath. Not because we fully understood it, but because we had to. Because to live beside something so vast, so capable of undoing everything required a story, or a symbol. Something to wrap the fear in, like a blanket wrapped around flame. Every culture has a version of this. In Hindu mythology, there is Shiva, the destroyer, yes, but also the transformer, the end of things, but also the beginning. In one sacred text, the Bhagavad Gita, a god reveals his cosmic form, and a prince sees all of time and death unfolding at once. Centuries later, J. Robert Oppenheimer, watching the first nuclear test ignite the desert sky, would recall that verse, "Now I am become death, the destroyer of worlds." It wasn't a calculation. It was recognition that what they had built resembled something ancient, something divine, or perhaps demonic, a flame from myth, now real. In Norse legend, there's Ragnarok, the twilight of the gods. When fire swallows the earth, the skies are torn and the world is remade from ash. In Christian scripture, Revelation brings trumpets and plagues and flames and final judgment. In Native American traditions, stories speak of cycles, worlds born, destroyed, reborn, not as punishment, but as rhythm, a pulse as old as time itself. In every corner of the world, people have carried this idea, that fire can cleanse or end or transform, that something vast will one day return what was given, and maybe that's why the nuclear bomb feels so familiar, even though it's so new. Because it fits a shape we already feared. It mirrors old anxieties, ancient dreams. It is not just a weapon of science. It's a myth reawakened. Even the way we talk about it carries echoes of story. Mushroom cloud, fallout, ground zero. Each phrase is oddly poetic, like something lifted from prophecy or epic verse. The kind of language that would feel equally at home in a scripture or a saga. And maybe that's not accidental. Because when we cannot make sense of something through logic alone, we reach for metaphor, for symbol, for ceremony. After Hiroshima and Nagasaki, survivors describe not just the heat and the sound, but the silence that followed. Birds gone, shadows burned into walls, people turning to smoke. There were no words for it, only fragments, images, stillness. In Japan, the word hibakusha emerged. Explosion affected people, not soldiers, not enemies, just people caught in something too large to name, and across oceans people lit candles, or fell silent, or argued. Some cheered, some wept, some pretended nothing had changed, but something had. The age of myth had become mechanical. We had reached into the sky for lightning, and caught it. But the strange thing is, we'd been trying for centuries. The ancient Greeks believed that all matter was made of indivisible building blocks, atoms, though they had no instruments to see them, just thought experiments and wonder. They imagined motion, void, and the dance of particles before the microscope had even been conceived. In medieval alchemy, the dream was transformation, lead into gold, mortality into eternity. Fire was key, always fire, and symbols were drawn of flasks and furnaces and things being purified, released. And later, during the Industrial Revolution, steam and coal and combustion became symbols of progress. Energy meant motion, heat, speed. We built machines, then cities, then empires, all powered by increasingly refined versions of fire. But still we were working with the outer layers of nature. Coal is old wood. Oil is ancient sunlight. Even fire itself is just a reshuffling of chemical bonds. Impressive, yes, but still surface level. The idea that energy could lie within matter itself, locked in the very particles of atoms. That idea belonged to the 20th century, and when it arrived it came not as a gentle whisper, but as an experiment gone critical, as chain reactions and neutron multiplication and suddenly equations that ended in fire. But again, we wrapped it in ritual. The first nuclear test, codenamed Trinity, was scheduled at dawn. Scientists watched from bunkers. Some wore sunglasses, some didn't. Some thought the atmosphere might ignite. Others took bets. And when the bomb went off, silence followed. Not celebration, not triumph, just silence. Not because it hadn't worked, but because it had. And deep in that silence was something very old, a feeling that the world had just shifted in a way it couldn't shift back. Oppenheimer, in recalling the Gita, wasn't trying to be poetic. He was trying to find an anchor in a moment that defied anchoring. Because myth is how we metabolize the unthinkable. In the years that followed, as more bombs were tested, underwater, underground, in the upper atmosphere, new rituals emerged. Warning sirens, fallout shelters, duck and cover drills in schools, survival manuals. These were not just practical responses. They were, in their way, cultural myths. Ways of saying, here is how you survive the end of the world, even if, deep down, we weren't sure anyone could. And in response, art shifted. Films imagined wastelands, books explored mutants, bunkers, post-apocalyptic scavengers. Even comedies, like Dr. Strangelove, found dark humour in absurdity. Because sometimes laughter is the only tool left when awe turns to anxiety. But not every culture reacted with fear. In the Soviet Union, atomic imagery became a symbol of strength, of mastery over nature. Posters showed atoms as flowers, bombs as guardians of peace. In the US, the atomic age was marketed as modernity itself. Atomic toasters, atomic cocktails, atomic optimism. It was as if, by domesticating the symbol, we could make the danger feel less real. And maybe, on some level, that worked. But beneath the branding, the mushroom cloud lingered. A new god in the pantheon, or perhaps an old one, reborn in fission. Even languages absorbed the weight of the bomb. In English, we now say things blew up, even if we mean popularity, not destruction. We talk about nuclear options in business. We use the idea of fallout to describe emotional aftermath. We borrow the terms because we felt them once, or still do. And in that way, the bomb became not just a weapon, but a metaphor for power, for escalation, for the things we unleash that we cannot fully recall. There are also traditions, quieter ones, that try to answer the bomb not with bigger explosions but with gentleness. In Japan, each August, lanterns are floated down rivers in Hiroshima and Nagasaki, glowing, silent, bearing the names of the dead. It's not protest, not politics, just remembrance. The opposite of flash and fire, a whisper that says, "We were here, we remember, let it never be again." And that too is culture, because history is not just events, it's how those events ripple, how they change rituals, language, imagination, how a single morning can echo for generations. Even now, many decades later, the nuclear shadow remains. We don't speak of it daily, but it's there, in treaties, in silos, in vaults and policies and launch codes, in climate simulations, in stories whispered by grandparents who once saw two suns rise. And even in places where no bomb ever fell, the idea of it changed things. It taught us that no place is truly distant, that power is global, that silence can be deeper than sound. But more than that, it taught us something mythological, that knowledge is not neutral, that to split an atom is not just to understand the universe, it's to change the universe, to tilt it, to rethread the web of meaning. And this is deeply human, because all our greatest powers come with this dual nature. Fire can warm or burn, water can nourish or drown, words can comfort or cut. And so too with the atom, it can light cities or level them. It is not good or evil, it is potential, and we, always, are the ones who decide how that potential is shaped. So yes, the nuclear bomb is destructive, devastatingly so. But it is also a mirror, a reflection of how far we've come and how carefully we must tread. And perhaps that is why cultures across time and space have always returned to the same questions. What do we do with power? Who gets to hold it? And what story do we tell ourselves? When the fire starts speaking back, let's start very small. Smaller than dust, smaller than cells, smaller than anything you've ever held in your hand. Atoms. They are the scaffolding of reality, the quiet architecture behind every leaf, every breath, every stone. For most of human history, we didn't know they were there. We sensed structure, of course, that things could be divided, that matter had layers, but it wasn't until the last century or two that we began to see them, or at least infer them with a kind of trembling certainty. And once we did, the universe opened. Because atoms are not solid spheres, they are mostly space, like little solar systems, with a heavy nucleus at the centre, protons and neutrons huddled tight, and electrons dancing in orbits around them. But if you were to pluck one of those atoms from the air right now, say, a nitrogen atom from your exhale, and you were to look closely, magnified 1 trillion times over, you'd find that the real drama is happening deep inside that nucleus. That's where the energy waits, not in the electrons, not in the outer rings, but in the tight, quiet space where protons and neutrons cling together. Because here's the beautiful, terrifying truth, that nucleus is holding more energy than it seems to have any right to contain. You see, protons are all positively charged, and like charges repel. So in theory, they should be pushing each other apart, but they don't. Why? Because of something called the strong nuclear force, one of the 4 fundamental forces in nature, and the strongest by far. It works only at tiny distances, but within those distances it's powerful enough to glue protons and neutrons together, even when the protons are trying to escape. It's like a cosmic scale game of trust, tension wrapped in balance, and as long as that balance holds, the atom is stable. But if you disrupt it, if you take certain kinds of atoms, like uranium-235 or plutonium-239, and you disturb that delicate nucleus in just the right way, you can cause it to split. This is called fission. And the moment it happens, something extraordinary is released. Imagine dropping a tiny pebble into a still pond. Now imagine the pond explodes. That's the scale of change we're talking about. When the nucleus splits, it throws off more neutrons, and these neutrons go careening into nearby nuclei, which also split and send off more neutrons. And suddenly, like a fire racing across dry grass, you get a chain reaction. Each step releases more energy than the last. Not fire, not flames, but raw, searing energy, in the form of heat, light, and pressure. And here's the part that still feels like science fiction. The total amount of material required for this chain reaction to be devastatingly powerful is tiny. The bomb dropped on Hiroshima used less than 1 kilogram of uranium-235 in its core. Only a fraction of that underwent fission, and yet the energy released was equivalent to about 15,000 tons of TNT. That's the power of E-man mc2, Einstein's deceptively simple equation that tells us energy and mass are interchangeable. A little bit of mass, just a whisper of material, can be turned into a storm, because c2, the speed of light squared, is not a small number. It means that even a gram of matter, if fully converted, could produce an explosion large enough to level city blocks. But bombs, of course, are not about elegance. They're about mechanics. And to turn a theory into a weapon, you need a design. There are different ways to trigger a nuclear explosion, but 2 designs became iconic in the early days. The first, used in Hiroshima, is called a gun-type bomb. It works like this. Imagine 2 subcritical pieces of uranium, not quite enough on their own to sustain a chain reaction. But if you fire one into the other, using a small explosive, they combine into a single supercritical mass, and the chain reaction begins. It's surprisingly straightforward. 2 halves, 1 sudden union, and then silence gives way to light. The second design, used 3 days later in Nagasaki, is more complex, the implosion-type bomb. Instead of slamming 2 pieces together, this one uses a core of plutonium surrounded by carefully arranged conventional explosives. When these outer explosives detonate, they compress the plutonium inward, squeezing it into a supercritical state. It's not an explosion outwards, but a crushing inward, forcing the material to a density where the chain reaction can unfold all at once, and unfold it does. In microseconds the reaction begins. In the next millionth of a second, a fireball forms, hotter than the surface of the sun. Temperatures reach tens of millions of degrees. The air itself becomes plasma. The bomb doesn't just explode, it creates a miniature star for a heartbeat here on Earth. But that's only the beginning, because all that energy pushes outward, compressing the air around it into a shock wave. This is the blast, the first and most immediate force of destruction. It travels faster than sound, flattens buildings, breaks glass miles away, turns walls into shrapnel. Then comes the thermal radiation, heat intense enough to ignite fires, melt skin, turn sand into glass, and finally, the ionizing radiation, invisible but deadly. Neutrons and gamma rays that damage living cells, cause radiation sickness, leave long-term effects in bone marrow, DNA and memory, and all of it, in the first seconds. It's this speed that our minds struggle to grasp, that such immense destruction doesn't take minutes or hours or days, but moments. The bomb does not wait, it does not announce, it simply is and then was. And then comes the silence, the vacuum left behind, the quiet that follows the roar, dust rising in strange spirals, ash where people once stood, echoes where there were once voices. In the centre of the blast, temperatures were so high that shadows were burned into stone, the only trace left of those who had been standing there. It's the speed and scale, again, that our brains push back against. Because this is not just an explosion, it is conversion of matter into energy, of theory into reality, of ordinary life into something that cannot be named, and it all begins with a nucleus, with the tiniest balance of forces, with protons held in place by the strong nuclear force and the quiet waiting of a neutron wandering too close. Even the word critical takes on new weight here. In physics, a critical mass is the amount of fissile material needed to sustain a chain reaction. If you have less than that, the reaction fizzles. More than that, and the energy cascades. But critical also means pivotal, irreversible, a moment after which everything is different. And that perhaps is the truest description of a nuclear explosion. It is a critical moment in every sense. 1 second you are in a world you know, with streets and shoes and windows and clocks, and the next, that world is gone, and no one ever really expects it. Even in the desert at the first test in July 1945, the scientists stood in protective shelters but watched with open eyes. Some were afraid the atmosphere would ignite. Others believed the bomb might be a dud. Some hoped, secretly, it wouldn't work. But it did. The sky lit up before the sound arrived. The desert glowed, and in that strange dawn, a new age began. The atomic age, not just of bombs, but of understanding, of reckoning, of knowing for the first time that the universe's deepest forces were not locked away in distant stars, but right here, in our hands, in the dust we breathe, the water we drink, the bones beneath our skin. It's all atoms, it's all energy, and under the right, or wrong, circumstances, it's all potential. That's what makes the nuclear bomb so destructive. Not just the mechanics, not just the heat or the radiation or the blast radius, but the fact that it's a reminder that nature holds powers we barely comprehend, and that sometimes, when we learn to unlock them, we forget to ask if we should. If the blast is the beginning, then what follows is the echo, not in sound, but in matter, because a nuclear bomb doesn't end when the fireball fades. In some ways, that's when it really begins. In the moments after the explosion, as the shockwave rolls outward and the world still trembles, the remnants of the bomb and the city and the soil and the people begin to rise. Carried upward by the heat of the fireball, debris and vaporized material swirl into a towering column. At its peak, it begins to flatten and spread. That strange, unforgettable shape, the mushroom cloud. It isn't just smoke, it's not just dust, it's fused particles of bomb casing and earth and bone and metal, all made radioactive by the explosion, bits of plutonium, fission products like iodine-131, cesium-137, strontium-90, each with their own half-life, their own eerie kind of clock. This is fallout. The word sounds soft, almost accidental, but it's anything but gentle. As the mushroom cloud cools, gravity begins its quiet work. Particles begin to drift downward, sometimes quickly, sometimes over days. They fall on rooftops, on riverbeds, on people's skin, on food, on crops, on the soft fur of animals. And because they're radioactive, they don't simply land, they linger. This is one of the most haunting aspects of nuclear weapons, that they keep working long after they've done their worst, that they continue to reshape bodies, ecosystems, timelines, invisibly. Radiation is not a thing we can see or smell. It doesn't glow green or buzz ominously. It's quiet, persistent, and its effects are subtle at first. A feeling of nausea, a sudden fatigue, a drop in white blood cells. But under the surface, damage is accumulating. Radiation affects living tissue by damaging DNA, the fundamental instruction manual for life. In small doses, the body may repair the damage, but in large or repeated exposures, the repair systems falter. Cells mutate. Some die. Others grow uncontrollably. This is why survivors of nuclear detonations face higher rates of cancers, leukemia, thyroid cancer, lung and bone and breast cancers, not always right away, but years later. A long echo. Children exposed in the womb may be born with deformities or suffer cognitive effects. Entire generations may feel the tremor of a bomb they never heard, and yet the radiation doesn't stop. Because some isotopes remain dangerous for centuries. Cesium-137, for example, has a half-life of about 30 years. That means in 3 decades, half of it decays, but the rest remains. After 60 years, a quarter is still there. After 90, 1/8, and so on, which means that the soil, the water, the bones of a city may carry the signature of the bomb long after its builders are gone. Even plants absorb it. Grains, mushrooms, grasses. Animals eat the plants. People eat the animals. It moves through the food chain like a whisper, invisible but potent. And in places where tests were done, deserts, atolls, open sea, the land still tells the tale. In the Marshall Islands, on Bikini Atoll, where the US conducted dozens of nuclear tests, there are islands so contaminated that resettlement remains dangerous even now. Coconut trees grow, yes, but their fruit carries the memory of fallout. And it's not just external. Fallout has entered the atmosphere too. In the 1950s and 60s, as nations tested bombs in the open air, radioactive particles spread around the globe. Strontium-90 was found in baby teeth in cities far from any test site. Cesium rained down in snowflakes. Even now, traces of that era remain detectable in soils and sediments, in the bones of people born during the Cold War. It's as if the planet itself was briefly tattooed with radiation, a mark that says, this happened. Even the light of the bomb leaves a trace. Flash burns, the thermal radiation released in that first moment, can cause shadows to be permanently etched onto walls, not shadows cast by people but by their absence. Stones scorched around the outline of a body that was there one moment, gone the next. There are photographs of these shadows, on sidewalks, stairwells, bridges, impressions of bicycles, railings, a ladder, human forms mid-motion, paused forever in light. It's a strange kind of fossil, not of bone, but of being. But of course, the damage isn't just physical. Radiation has a psychological weight. There's a particular kind of dread that comes with the unseen, a fear not of explosion but of exposure, of time working against you in quiet, hidden ways, of an enemy that doesn't chase, doesn't roar, just waits. People exposed to fallout often spoke of feeling contaminated, not just biologically but spiritually, as if touched by something unclean, as if the body had betrayed them, or the world had. And sometimes that trauma passed to the next generation. Children of survivors carried stories they couldn't remember, but couldn't forget either. Nightmares of fire, of sirens, of silence, of sky. Even those born far away, years later, felt the edges of the bomb in the drills, the documentaries, the whispers, the quiet tension in their parents' voices when someone said atomic. That's the true complexity of nuclear destruction. It's not just about cities and blast zones, it's about time. Nuclear weapons stretch destruction across time. First the explosion, then the fire, then the radiation, then the silence, then the sickness, then the memory. And that memory lingers, even in science. Because to understand a nuclear bomb is to understand not just fission, the splitting of atoms, but also the systems designed to amplify, deliver, and maximize its effects. Modern weapons aren't simple anymore. They involve layers, triggers, reflectors, neutron initiators. Some are boosted, using fusion reactions to increase yield. Others are designed to detonate high above ground to maximize EMP, electromagnetic pulses that can disable electronics. There are thermonuclear weapons too, often called hydrogen bombs, which use a fission bomb to ignite a fusion reaction, like in the sun. These are not just city-destroying, they're continent-wounding. Their power is measured in megaton ranges, millions of tons of TNT. The largest ever detonated, the Tsar bomber, was tested by the Soviet Union in 1961. It released the equivalent of 50 megatons of TNT. Its fireball was visible from hundreds of miles away. Windows shattered more than 500 miles from the blast. The shockwave circled the globe 3 times, and yet, all of it still comes down to tiny particles moving in precise, merciless steps. That's what makes it so difficult to comprehend. That something built by people, engineered, calculated, assembled, can imitate a star, can echo creation itself, and that in doing so, it can unravel not just cities but certainty. After the first bombs were used, many scientists, those who had helped design them, fell into silence. Some resigned. Others wrote manifestos. They had been chasing knowledge, but they had built a weapon that outpaced knowledge. That questioned what progress meant, and that question still echoes. Because the science behind a nuclear bomb is not dark. It is beautiful in a way, balanced, precise. The dance of forces, the poetry of mass and energy, the elegance of conversion. It is the use that casts the shadow. The science does what it does. Neutrons don't vote. Plutonium doesn't dream of war. It is we who shape it, who decide whether atoms light cities or level them. And so we return, again and again, to the same quiet wonder. How can something so small do so much? How can the same particles that hold up the stars turn to fire in our hands? And what does it mean to hold that power? What do we do with it, late at night, when the headlines blur and the sky above our roofs stretches out into a silence so wide we can barely name it? Maybe, if nothing else, we remember that atoms are not just particles, they are poems. And like all poems, they can be read 2 ways, with awe or with sorrow, and sometimes both at once. So far we've spoken of fire, of matter split apart, of fission, the chain reaction that turns weight into light, turns silence into force. But that's only half the story, because fission was just the beginning. What came next was not just a bomb, it was a second sun, a mirror of the stars built by human hands, carried by aircraft, or perched on missiles in silent readiness. This is fusion. If fission is the splitting of atoms, fusion is their joining. It's what happens in the heart of the sun every moment. Hydrogen atoms under immense pressure and heat collide and fuse into helium, releasing vast amounts of energy in the process. The irony is that we started with fire and ended with light. Because fusion doesn't just destroy, it radiates. But to get there, you need something fierce enough to spark it. And so, in a grim poetry of design, fusion bombs, or thermonuclear weapons, use fission to start the fire that triggers fusion. A bomb within a bomb. Here's how it works. At the core of a thermonuclear bomb is a primary stage, a traditional fission bomb, not so different from the ones used at Hiroshima and Nagasaki. When it detonates, it releases heat, pressure, and X-rays, not to destroy immediately, but to compress a separate secondary stage nearby. That secondary contains fusion fuel, typically isotopes like deuterium and tritium, or a compound called lithium deuteride. But fusion won't happen on its own. It needs to be squeezed and heated to conditions found in stellar cores. And so, the fission explosion does just that. It implodes the secondary. It focuses its force inward, like lighting a candle with a lightning bolt. Within millionths of a second, the temperature rises to tens of millions of degrees, and in that pressure-cooked furnace, nuclei fuse, and fusion is explosive. It releases even more energy per gram than fission. The result is a blast of nearly unimaginable scale. The brightest flashes humanity has ever seen. The loudest silences. The most complete erasures of space. Thermonuclear weapons are not measured in kilotons but in megatons. 1 megaton equals 1,000,000 tons of TNT, but the numbers themselves blur, because after a certain point the mind no longer measures. It just flinches. The largest bomb ever detonated, the Tsar Bomba, was originally designed to yield 100 megatons. It was scaled down to 50 for the test. Even so, its fireball stretched over 5 miles across. Windows shattered hundreds of kilometers away. The seismic waves circle the planet. The mushroom cloud reached into the stratosphere like a hand grabbing the sky. And yet, it was still just a test, a demonstration. Which begs the quiet question, how much power is too much? And more importantly, who decides? But not all nuclear weapons are designed for sheer size. Some are built for subtlety, precision, specific kinds of damage. Take the neutron bomb, for example, also known as an enhanced radiation weapon. It's a strange concept. A bomb designed to release more radiation and less blast. The idea is this. When you detonate a standard nuclear bomb, much of the energy goes into heat and pressure. But with careful design, you can increase the number of neutrons released, especially high-energy fast neutrons. These pass easily through armor and walls, damaging living tissue far more than structures. In theory, a neutron bomb could be used to neutralize soldiers or crews inside tanks and bunkers, while leaving the building standing. It's a deeply uncomfortable idea that we could tailor destruction so surgically, so coldly, that life ends but furniture remains. And yet such weapons were built. Not widely deployed, but possible. Another kind of edge case is the dirty bomb. Not technically a nuclear bomb at all, but a radiological dispersal device. Imagine a conventional explosive, a simple chemical bomb, laced with radioactive material. When it explodes, it doesn't vaporize a city, but it spreads contamination, panic, poison, radiation, over streets and buildings. Less energy, more dread. Dirty bombs are not strategic weapons, they're psychological ones, designed to frighten, to displace, to make places unlivable without lifting a single stone. But there are more curious cases too. Did you know that some nuclear bombs are designed not to explode, but to fail safely? They're called fail-safe designs, and they use something called insufficient criticality as a safety measure. A weapon that's damaged, dropped from a plane, burned in a fire, struck by accident, should not detonate. And so, scientists design them so that multiple specific steps must occur in sequence. Explosive lenses, neutron initiators, arming codes. Otherwise the bomb simply doesn't go off. And yet the materials inside still could. This brings us to subcritical accidents, also called fizzles, or accidental criticality events. These are unintentional chain reactions that don't quite reach bomb-level yields, but still release energy, and often radiation. Throughout history, there have been terrifyingly quiet moments in labs, factories, during transport, where materials were arranged in just the wrong way. Too much fissile mass in a vessel, a reflection from polished surfaces focusing neutrons, a spilled bucket, a technician leaning too close. In such cases, a sudden blue flash can appear, called a Cherenkov glow, the eerie light of particles moving faster than light through water or air. Some died instantly, others days later. The events are now studied with reverence. Cautionary tales etched in shielding glass and declassified reports, and it all underscores the same truth. Fission is not patient. It does not ask if you're ready. It does not forgive errors. That's why nuclear weapons, beyond their design, require entire infrastructures to contain them. Vaults, permissive action links, coded locks, environmental controls. The weapon itself is small, but the web of safeguards wrapped around it is vast, and even then, things go wrong. There have been dozens of incidents, near launches, false alarms, miscommunications, a training tape played by accident, a flock of birds mistaken for missiles, a software bug. And each time, the world came closer than it should have to disaster, because the science may be cold, but the hands that guide it are human, and humans, beautiful and fallible, sometimes forget. That's why redundancy is everything in nuclear design. Multiple layers, multiple conformations. No single person can launch. No single system decides. It's not trust, it's distrust, designed into the code, the circuitry, the protocol. It's the science of doubt. Because with this much power, doubt becomes wisdom. And yet, the dream of control can never be total. Because even if the weapon works perfectly, the world around it may not. Winds change, civilians wander, earthquakes strike, and so, scientists simulate, endlessly. Computer models of blast radius, fallout patterns, neutron flux. Supercomputers running war games and yield equations. The bomb itself may not be tested anymore, but its ghost is rehearsed daily. And still, there's more. Radiation science isn't just about destruction. It's a whole branch of physics and medicine. It helps treat cancers. It powers deep space probes. It scans ancient bones and artifacts. But once it's tied to the bomb, everything shifts. Because in a bomb, radiation is not a tool. It's a weapon, not a healing beam, but a storm. And it's not just about human tissue. Radiation affects ecosystems. Subtly, profoundly. After nuclear tests in the Pacific, fish populations dwindled. Coral bleached. Seabirds laid eggs with thinner shells. After Chernobyl and Fukushima, animals fled, then returned. Wild boars, wolves, elk. In the absence of people, the forests grew back. Not untouched, but wild again. And in the soil, in the bones of insects and birds, the isotopes remain. It raises a haunting question. How long will the Earth remember us? How long will the cesium in the silt, the plutonium in the bones, the shadows on the walls, tell our story? And what story will it tell? Because science cannot unbuild the bomb, but it can show us what it does. It can measure and model and mourn. It can whisper warnings in half-lives and decay chains, and so we listen, not with panic, but with care. Because knowledge is not just about power, it's about humility, about standing before the atom, this tiny sun seed, and realizing what we've made from it. Not just the bomb, but the choice. Let's begin in the desert. In the American Southwest, where the air is dry and the stars come close at night, a place called Yucca Flat still carries the marks of an age that tried to understand destruction by practicing it. From the 1950s to the early 90s, the Nevada test site was the setting for over 900 nuclear detonations. Some above ground, most below. They called it testing, science, national security. But when the shockwaves came, they rippled through more than soil. Some of the tests had names like Upshot Knothole, Operation Plum Bob, Sedan. The Sedan test alone displaced over 11 million tons of earth, creating a crater more than 1,200 feet wide. From the air, it looks like the scar of a giant's footprint, a reminder that sometimes understanding comes at a cost. But not all tests were about bombs, some were about people. In the early years, militaries conducted experiments to study the effects of nuclear blasts on soldiers. Troops were positioned in trenches just miles from ground zero. After the explosion, they were ordered to rise, walk toward the cloud, occupy the field. They were told the risks were minimal. Many were not told much at all. And so, a generation of men inhaled dust, drank contaminated water, watched fire rain from the sky, and went home. Some were fine. Others, years later, were not. They became known as atomic veterans. Their illnesses were often dismissed, their records sealed, their stories whispered, then recorded, then finally, decades later, acknowledged. Some received medals, others never heard an apology, but the radiation remembered. Elsewhere, tests studied animals. Pigs were strapped into harnesses, dogs placed in cages, cameras recorded their reactions, their injuries, their deaths, and mannequins, human-shaped, dressed in shirts and skirts, were arranged in suburban mock-ups, complete with furniture, sidewalks and mailboxes. Whole fake towns built, then destroyed to observe what would happen if a bomb fell on an ordinary morning, what melted, what caught fire, what was left behind. It was called civil defense, and in its own way, it was. Because even within destruction, there was an effort to learn, to minimize, to know. And so we asked, how long does glass take to melt in a fireball? How far can a wooden house be from the center and still stand? How does radiation drift on a cloudy day? In some tests, balloons were sent aloft to measure gamma rays. In others, sand was turned into glass, forming a greenish substance called trinitite, a souvenir of the first nuclear blast. Even now you can find pieces of it, smooth, slightly iridescent, quiet. They look like sea glass, but they are not born of waves. They are the skin of Earth, flash-fused by the breath of a bomb. And if you hold one in your hand, it's not just history you feel, it's something else, something unshakably present. Because the thing about nuclear material is that it doesn't fade easily. Even after decades, some isotopes remain dangerous, others decay, but into daughters that are also radioactive. The timeline stretches, the risk shifts, but the presence persists. This is one of the strangest aspects of nuclear science, the timescales. We think in hours, days, maybe years, but radiation thinks in centuries. Plutonium-239 has a half-life of 24,000 years. That means if you bury it today, it will still be half as radioactive in the year 26,000 AD, and half again in 28,000. Which leads to a quiet dilemma. How do you warn the future? At sites like the proposed Yucca Mountain repository, scientists and artists tried to answer that question. How do you create a sign that says, danger, do not dig, do not touch, not safe for 100 generations? You can't assume language will last, or symbols, or even recognizable alphabets. And so they proposed vast black pyramids, fields of thorns made of stone, carvings that say, this is not a place of honor. Nothing valuable is here. It's not just engineering, it's psychology, it's archaeology projected forward, a message from the past that tries not to be misunderstood. But we know, of course, that we forget. Humans forget things all the time. Not just passwords or anniversaries, but patterns, warnings, whole disasters. We move on, we rebuild, we repaint the signs, we rename the streets. And so nuclear science walks a razor's edge between permanence and forgetfulness, between what is buried and what still breathes in the air. And the forgetting isn't just about time, it's also about comfort. Because the bomb is not in the headlines every day, it's not in classrooms, it's not part of daily conversation, and so it fades into old footage, into Cold War films, into documentaries on Sunday afternoons, but the weapons are still there. Thousands of them, ready, maintained, coded, cooled. They sit in bunkers, in submarines, in vaults of reinforced concrete beneath prairie grass and snow. And they are still governed by physics, the same equations, the same thresholds, the same quiet neutron that begins the chain. It's tempting to think of nuclear weapons as relics, as dusty things from history rusting in peace. But they are not relics, they are ready, and that readiness rests on restraint, a balance of policies, tensions, treaties, and people, always people. Which is why, perhaps the science is not the scariest part, the science is beautiful, clean, logical. It's the use that's messy, the intent, the fear, the mistakes. That's why so many physicists, especially those who helped build the first bombs, later became advocates for peace, because they had seen the math, but they had also seen the sky catch fire, and they understood something the rest of the world was still trying to grasp. That knowledge, once gained, cannot be returned, that the fire, once lit, does not unburn. And yet, here we are, still asking, still listening, still holding our breath in the long pause between invention and intention. And maybe that's what this all comes back to. Not the blast, or the yield, or the crater, but the pause, the seconds before a test, the breath held before a button is pressed, the silent drift of fallout over fields that once grew wheat, and the knowledge, deep and unshakable, that we have built something vast, something that turns mass into memory, cities into statistics, families into shadows on walls, and that with each passing year the science becomes more precise and the morality more uncertain. Yet within all this there is a kind of clarity, a kind of quiet, because at the edge of destruction, understanding becomes sacred, and sleep, perhaps, becomes an act of hope, that we will wake in a world still spinning, that the atoms tonight will remain still, that light will come only from stars and lamps and screens, and not from a sudden second sun, that silence will remain only silence, not the kind left after fire, but the kind we choose, the kind we protect, the kind that lets us rest. It didn't begin with a bomb, it began with a question. Thousands of years ago, when fire was still considered sacred and thunder was the voice of gods, early thinkers in Greece, India, and China began to wonder what everything was made of. Not in a laboratory, not with microscopes or equations, but with thought and silence and long walks under the stars. What if everything could be divided, again and again, until there was a smallest piece, a bit so small it could not be cut further? The Greeks called it atomos, indivisible. They had no way to prove it, no way to see it. But they imagined it anyway, that the universe, for all its chaos and change, might be built from tiny, stable building blocks. A quiet, hopeful idea, like imagining the sky rests on invisible pillars. It would be over 2,000 years before the atom became more than a whisper. In the early 1800s, a quiet English school teacher named John Dalton began to revive the idea, not as philosophy but as chemistry. He studied gases, weights and reactions, and concluded that matter behaved as though it were made of distinct particles. He called them atoms, gave them symbols, made tables. He had no microscope, no X-rays, no nuclear reactors. Just careful measurements, a sharp pencil, and a curious mind. And from those measurements, the modern journey began. By the late 19th century, new discoveries arrived like constellations appearing one by one in a dark sky. J.J. Thomson, tinkering with cathode ray tubes in 1897, discovered the electron, a tiny, negatively charged particle that seemed to orbit inside atoms. Suddenly, atoms weren't indivisible anymore. They had parts, structure, complexity. Just a few years later, in 1905, a young patent clerk named Albert Einstein would publish 4 papers in a single year that redefined physics. One of them, on Brownian motion, helped prove that atoms actually existed. Another, of course, introduced the world to an equation that would echo through eternity. E mc2, energy equals mass, times the speed of light squared. It was elegant, compact, and deeply unsettling, because it meant that mass wasn't just heavy, it was potential, that even the tiniest bit of matter contained an astonishing amount of energy, if only we could find the key to unlock it. But that key hadn't been found yet. In 1911, Ernest Rutherford, using a clever experiment with gold foil and alpha particles, discovered that atoms were mostly empty space, with a dense central core, the nucleus, and within that nucleus, protons. Later, James Chadwick would find the missing puzzle piece, the neutron, uncharged, quiet, yet critical. The stage was set, the parts were there, but no one had yet imagined splitting the atom, not truly. That moment came in 1938, in a quiet laboratory in Berlin. Physicists Otto Hahn and Fritz Strassmann bombarded uranium atoms with neutrons. To their surprise, the uranium didn't just absorb the neutrons, it broke apart. Austrian physicist Lise Meitner working in exile, would interpret the results. She saw what others missed. This was fission. The nucleus had split, and in doing so, released energy far beyond a normal chemical reaction. She and her nephew, Otto Frisch, ran the numbers. It wasn't a trick, it was real. The atom could be broken, and when it broke, it released not just energy, but more neutrons, the seeds of a chain reaction. This was December 1938. By the following year, physicists around the world understood what this meant. It was no longer theory, it was a pathway, and the world was about to walk it. In 1939, as war brewed in Europe and refugees fled fascism, a letter arrived at the desk of US President Franklin D. Roosevelt. It was signed by Albert Einstein, but written by physicist Leo Szilard. The letter warned that Germany might attempt to build a bomb using uranium. That fission was real, that a chain reaction was possible, and that, for the first time, the physics of the universe offered a weapon like no other. Roosevelt listened, and so the Manhattan Project began. What followed was one of the most extraordinary scientific mobilizations in history. Laboratories sprouted in secret in Los Alamos, Oak Ridge, Hanford. Thousands of physicists, chemists, engineers and technicians worked in hushed urgency. They solved puzzles no one had faced before: how to enrich uranium, how to create plutonium, how to build lenses that could compress a core evenly, how to ignite a chain reaction not just once, but perfectly every time. Among them were legends in the making: Enrico Fermi, who built the first nuclear reactor under a football stadium in Chicago; Richard Feynman, who would later bring physics to life on chalkboards and in books; J. Robert Oppenheimer, the poet-physicist who led the effort at Los Alamos and watched fire rain from the sky. And on July 16, 1945, in the desert of New Mexico, the first atomic bomb was detonated. Trinity. The codename was poetic, quiet, almost sacred. The bomb was not. The explosion lit the sky in colours no one had words for. The sand turned to glass. The sound came late, like a god clearing his throat. Those who watched were silent. They knew. In that instant, they knew the world had changed. A few weeks later, 2 cities, Hiroshima and Nagasaki, were destroyed. The war ended. But something else began: the atomic age. The years that followed were filled with tension. Science was no longer just exploration, it was leverage, power, balance, deterrence. The Soviet Union tested their first bomb in 1949. The arms race began. Soon after, hydrogen bombs were developed, fusion-based, many times more powerful than fission weapons. The science accelerated. Satellites, ballistic missiles, submarines with reactors, power plants, medical imaging, radiation therapy, nuclear propulsion, some of it peaceful, some of it poised on a trigger, and yet in the midst of this something gentle persisted. Awe. Even those who built the bombs could not deny it. The atom had once been a symbol of unity, the smallest piece of everything. Now it was also a symbol of division, of potential, of fear. But the journey was never just about weapons. It was about knowledge, curiosity, the unrelenting desire to understand what the universe is made of. And we did understand, more than ever before. We discovered quarks, the smaller building blocks of protons and neutrons. We built the Large Hadron Collider to smash particles together at nearly the speed of light, recreating the moments after the Big Bang. We studied radioactivity, not just to destroy, but to diagnose, to treat cancer, to understand the age of rocks and the lives of stars. We mapped the decay chains of isotopes, tracing how elements transmute over time, uranium to thorium to radon to lead. And always, we remembered the half-life, the idea that something decays but never quite disappears, that time leaves fingerprints but rarely gives back what was lost. And maybe that's the deepest legacy of the nuclear age. Not the bomb, not the power, but the reminder that science is not separate from us. It is us, our wonder, our questions, our choices, and that every discovery, every new truth arrives with a quiet whisper, "What will you do with this?" The history of nuclear science isn't just a march of inventions, it's a story of thresholds, moments when the world could not go back, the splitting of the atom, the building of the bomb, the glow over the desert, and in each moment a choice to build, to break, to remember, to forget. We often tell history as a sequence of events, but perhaps it's more like a chain reaction, each moment triggering the next, energy begetting energy, memory igniting memory, and within that chain, humanity, bright, brief, trembling with potential. And maybe, as we drift now into sleep, the history lingers not in facts or dates, but in feeling. The feeling of standing at the edge of something vast, of seeing deeper into the fabric of matter than ever before, and of wondering, softly, endlessly, what we will become now that we know. Let's imagine for a moment that you're standing on a quiet hill miles from any city. The sun has just set, the air is still, the stars are beginning to appear, faint, then clearer, then bright. And in that silence, you look up at the sky and ask a question that doesn't quite have words. What is this? What are we doing here? What does it mean that we can build something like a nuclear bomb? It's a strange thing, isn't it? To be a species that can name galaxies, split atoms, build a sun in the palm of its hand, and still not fully understand why it cries or dreams or loves so fiercely it forgets to eat. And maybe that's where the discomfort begins. Because a nuclear bomb isn't just an invention, it's an expression, a mirror, a signal flare to the universe that says, we have touched the edge of creation and used it for destruction. It feels impossible, and yet it's real. So what does that mean? Let's start, as so many questions do, with a paradox. The bomb is both the pinnacle of scientific understanding and the collapse of moral certainty. It is precision, logic, clarity, and also horror, ambiguity, despair. It proves we are brilliant and reminds us that we are not always wise. And this duality, this deep contradiction, is not new. Ancient myths understood it well. In Greek mythology, there's the story of Prometheus, who stole fire from the gods and gave it to humans. As punishment, he was chained to a rock, his liver eaten daily by an eagle. Fire in this story is a gift, a revolution, and also a trespass. Something sacred taken too soon. And isn't that how the bomb feels? Like a knowledge that was meant for later, for someone wiser, like we opened a door and found not a room, but a cliff. Or consider the tale of Pandora. A jar is opened. Out flies everything, disease, war, suffering. But at the bottom, hidden beneath all the chaos, is hope. What a strange ending, that the last thing left is the one thing that cannot be measured. And perhaps that too is the story of the nuclear age, a story where terror and potential exist side by side, where what we fear most sits next to what we might someday learn to hold gently. Because what is the bomb really? At its most literal, it is mass turned into energy, a conversion, a transformation. But metaphorically, it is a wound in time, a moment when history split, like the atom, and created a before and an after. Before, a world that could go to war without ending itself. After, a world where every calculation includes the possibility of unmaking. We live in the after now, quietly, often unknowingly. But it's there, that hum, that possibility, woven into treaties and headlines and unspoken fears. It's the sense that no matter how stable the ground feels beneath your feet, something vast is always asleep beneath it. So how do we live with that? How do we go on with birthdays and grocery lists and lazy Sundays, knowing what we know? Some would say we compartmentalize. We forget. We shrink the problem until it fits in the news cycle, then let it drift away. Others turned it into metaphor. The bomb becomes a symbol of hubris, of progress, of everything we can do but maybe shouldn't. Still others build movements, march, advocate, hope that reason will win. But beneath it all, there's another truth, something quieter, the idea that the bomb forces us to reckon with our nature. Because unlike a volcano, or an earthquake, or even a pandemic, the bomb is not something that happened to us. It is something we made. We designed it, engineered it, chose it. And so its existence asks a question we usually avoid. What kind of creature builds its own extinction? Are we just clever apes with better tools? Or are we something else? Something evolving, not just in intelligence, but in conscience? The philosopher Bertrand Russell once said that the bomb did not so much threaten humanity as test it. He believed that the only way we could survive was by developing a new way of thinking, one that prioritized cooperation over conquest, dialogue over dominance, a shift not in science, but in soul. Others, like Albert Camus, saw the bomb as the ultimate absurdity, proof that we had created meaning without morality, brilliance without boundaries. And yet, even he didn't give up. Even Camus, who believed the universe was cold and indifferent, still called on people to choose peace, to act, to try. Because choice, that slippery, beautiful thing, remains, even in the shadow of the bomb. And here's where the philosophy turns strange. Because there are those who argue that the bomb in its terrible way has prevented wars. That knowing we could destroy everything makes us more careful, more restrained. It's called mutually assured destruction, a phrase so tidy it sounds almost polite. You don't bomb me, because I'll bomb you, so we both survive. It's a peace, yes, but a fragile one. A peace built on the edge of a knife, a world where silence is safety, where the loudest thing is restraint. And that's the strange thing about nuclear weapons. They are too powerful. They've made war, at least at that scale, irrational. And yet we still build them, stockpile them, upgrade them. Why? Because we don't entirely trust ourselves. Because somewhere deep down, we still believe in the story of Cain and Abel, that even brothers may strike, that fear is safer than faith. But imagine, just for a moment, another path. One where the bomb is not the end of the story, but the turning point. A moment where humanity sees what it is capable of and chooses something different. After all, the bomb teaches us something else too, that everything is connected. Fallout doesn't stop at borders, radiation doesn't check passports, the wind carries particles from desert tests to distant cities. The effects last longer than empires. Maybe that's what global truly means, and in that shared vulnerability, there's possibility. Because vulnerability, when acknowledged, becomes empathy. And empathy, when practiced, becomes survival. Perhaps the bomb, paradoxical, devastating, has given us a strange gift, a mirror so clear we cannot look away, a reminder that knowledge must come with care, that intelligence without wisdom is just a louder scream, and maybe, just maybe, that mirror is also a map, a guide to a future where science is not abandoned but humbled, where brilliance walks with gentleness, where power is never used to prove anything, but only ever to protect. And what about the stars? They shine every night, not because they are safe, but because they are far. But we brought that fire close. We built a sun and held it in our hands, not to warm, but to warn. And now we live in its echo. But perhaps too in its light. Because somewhere, in the same laboratories where weapons were designed, new miracles are being made, clean energy, particle therapies, fusion reactors that might one day power the world without poisoning it. The atom does not choose its use, we do, and in that there is still beauty, still hope, still the quiet potential of a species trying to grow up, slowly, imperfectly, into its own power. Maybe we are still Prometheus, still learning how not to burn. Or maybe we are something new, a kind of cosmic child, walking barefoot through forces it barely understands, learning, painfully, carefully, how to wield fire without destroying the forest. And maybe that's what the bomb means in the end. Not that we are doomed, but that we are awake, that we have seen what can be done, and are still here to choose what will be. And if that is true, if this moment still belongs to us, then maybe, just maybe, we have time. Not forever, but enough. Enough to imagine a world where science glows in cities, not in craters. Enough to whisper gently to those not yet born, we were afraid once, but we learned. We made something vast, and we learned to carry it with care. It doesn't start with a mushroom cloud. It starts with a noise, a flash, a memory, a dream you can't quite explain. And maybe that's the most human part of all this, that the nuclear bomb, though shaped by physics, lives in culture like a ghost, not in equations, but in stories, in movies, in bedtime warnings, in playground games and science fiction novels, in the way we grew up with certain words carved quietly into the back of our minds. Fallout, deterrence, Cold War, red button, mutually assured destruction. These phrases drift through daily life like vapour, hard to point at but always close, because once the bomb existed, it slipped into more than military strategy. It entered the collective subconscious, and there it settled. Let's start with childhood. For decades, children in many countries, especially during the Cold War, were taught to duck and cover. A school bell would ring, lights might flicker, and kids would scramble under desks, cover their necks, close their eyes. It was a ritual, practiced, rehearsed, like a fire drill, except instead of the burning building, it was the end of the world. Some children took it seriously, others laughed. Teachers told them, "This will help you survive." But even at a young age, many sensed it wouldn't. Because how do you hide from a sun? Still, the ritual mattered. Not for safety, but for psychology, for structure, for the fragile feeling that something could be done. And isn't that what we do with most fears? We frame them, shape them, teach them to fit inside routines. Even now in films and video games, the nuclear explosion has become a kind of visual grammar. The mushroom cloud is shorthand for apocalypse, the bright flash on the horizon, the countdown clock, the sirens, the silhouettes dissolving into light. We know these images even if we've never seen them in real life. They're burned into pop culture like shadows on a city wall. From Dr. Strangelove to The Day After, from Threads to Oppenheimer, the bomb became a character in our fiction. Sometimes tragic, sometimes absurd, sometimes silent, but always there, and not just in the West. In Japan, the bomb is not just a symbol. It is memory, experience, a wound. Hiroshima and Nagasaki are not metaphors. They are places where the air once turned to flame, where skin blistered in seconds, where people wandered through rubble with their shadows etched onto their backs. And that experience shaped Japanese culture profoundly, in anime, in literature, in rituals of remembrance. Every August, lanterns are floated down rivers in silent commemoration. Bells are rung, names are read, not for punishment, not for vengeance, but for the sake of not forgetting. And perhaps that is the quiet mission of all memory, to turn pain into pattern, to make sense of what cannot be undone. But the bomb's cultural presence isn't always mournful. Sometimes it's strange. There's a phenomenon called nuclear kitsch, novelty items that make light of atomic fear. Lamps shaped like mushroom clouds, comic books with radioactive superheroes, posters that say, "I survived the Cold War and all I got was this lousy fallout shelter." It's a kind of dark humour, a way of looking directly at the abyss and giving it a nickname. Because laughter is one of the oldest shields we have, and yet, even in jest, there's a tremor. Because the threat, unlike in most stories, never left. The Cold War ended, yes, walls fell, treaties were signed, but the weapons stayed. Thousands of them. In silos, submarines, briefcases. Their presence became background noise, muted but never silent. And so we built language to cope. Phrases like strategic stability, second strike capability, first use policy. Technical words papered over fear. It's like building a cathedral out of spreadsheets, but culture is more honest than doctrine. It reveals what we carry in our bones, and what we carry often is confusion. Because the bomb is not just fear, it's also fascination. It's fire and myth, science and sin, a technological marvel that horrifies and dazzles all at once. Think of the photos, black and white images of soldiers in goggles watching tests from behind dunes. Think of the eerie beauty of trinitite, green, glassy sand forged in heat. Think of the countdown, the silence before ignition. There's awe in it. Real, uncomfortable awe. And that too lives in culture. The bomb isn't just depicted as a villain. Sometimes it's a metaphor for ourselves. In Watchmen, it's tied to a godlike being who sees all timelines at once. In 2001, A Space Odyssey, the leap from bone to orbit hints that evolution and violence may always hold hands. In music too, the echoes are there. From Bob Dylan's warnings to Pink Floyd's cynicism, from Japanese protest songs to European techno tracks sampling Geiger clicks. The nuclear age has a soundtrack, and even silence sometimes feels like part of it. Because the quiet after a detonation, that long, surreal stillness, is not just physical, it's psychological. It's the gap between action and consequence. And in everyday life we feel versions of that gap all the time. We check the news and read about arms deals, about missile tests, about tactical options. Then we set our phone down, sip our coffee, water the plants. It's not apathy, it's dissonance. Our nervous systems were not built for this scale. We can imagine a fire, a flood, even a plane crash. But imagining a city vanishing, that's not fear. It's unreality. And so, we tuck the thought away. We build habits, we light candles, we talk about weather, books, errands. But somewhere, in the background, the idea hums. The idea that we live in a world where, if the wrong button is pressed, a Tuesday becomes a history lesson. And yet, we still live. We still write love letters. We still bake birthday cakes. We still fall asleep under blankets while rain taps the window. And maybe that's not ignorance. Maybe it's resilience. Because nuclear weapons may shape policy, but people shape culture. And culture adapts. We invent. We create. We reflect. We imagine. And imagination is powerful. It's what gave us the bomb. And it's also what gives us visions of peace. Because the world doesn't have just one story. It has many. And some of them end with cities burning, but others end with treaties signed, with silos dismantled, with scientists turning their skills toward healing instead of harm. In daily life, the bomb shows up in small ways, in the red X on a map, in the sticker that says nuclear free zone, in the classroom debate about deterrence, in the old film reel gathering dust in a library, in the books we read at 1 a.m, wondering whether anyone else lies awake thinking the same things, in the half joke someone makes at dinner, if the nukes drop, I hope I'm at ground zero. It sounds like gallows humour, but underneath is a soft truth. We don't want to suffer. We want it to be fast. Because what we fear isn't just death. It's the aftermath, the ache, the slow unravelling. And so culture paints the bomb in all its forms, as villain, as warning, as myth, sometimes even as memory. Because for those who lived through the Cuban Missile Crisis, or saw the glow at Trinity, or lost family in Japan, the bomb is not abstract, it's not a theory, it's the breath you held, the silence on the radio, the letter that never came, and culture remembers that, in books passed down, in songs sung low, in art that whispers rather than shouts. And maybe that's how we carry it. Not by denying, not by despairing, but by weaving the knowledge into the fabric of living, letting it inform without control, letting it guide without drowning. Because culture is not just expression, it's survival. It's the way we process what science alone cannot hold, and when it works, it heals. A mural in a city square, a poem taped to a lamppost, a child painting peace signs in crayon. These aren't solutions, but they're signals. They say, we know, we feel, we are still here. And maybe, late at night, when the headlines have quieted and the streets are dark, we remember that the bomb, for all its terror, also gave us a gift, the knowledge that life is fragile, and that every ordinary moment is extraordinary. A walk, a meal, a dream. Each is proof that we're alive in a world that could have ended, but didn't. Not today, not yet. And in that space between potential and reality, between shadow and sunrise, culture blooms, quietly, relentlessly, like grass through concrete, like laughter in a shelter, like sleep in the age of fire. Let's try something. Let's step sideways, not forward, not back, but into a version of the world that might have been. What if the bomb had never been built? What if the chain reaction had never worked? If the uranium stayed quiet? If the experiments failed? If the letter from Einstein had been lost in the mail? Would the war have ended differently? Would Hiroshima still be standing as it once was, wood and paper and life, untouched by the heat of a sudden sun? Or would someone else have found the secret later under different skies in a colder decade? Science, after all, does not ask permission. It follows questions, and the questions were already spreading. Through labs, through countries, through minds filled with numbers and neutrons and just enough fear. Maybe someone else would have done it first. Maybe the bomb was inevitable. But what if it wasn't? What if we had stopped? Drawn a line and said, no further. This knowledge is too heavy. Would we have buried it, sealed it, forgotten it? And if we had, would we be safer now, or simply unprepared for what another mind, another government, another moment might have made? That's the paradox. The bomb is both warning and weapon. Its very existence says, be careful, but its presence also says, be ready. So we live in that paradox, and we imagine. What if the bomb had never been dropped? The first one, Trinity, tested but never used. What if it stayed in the desert? A flash witnessed only by scientists, never civilians. Would the Cold War have looked different? Would the arms race have started slower? Would nuclear power still carry the same weight of fear? Some say the bomb had to be used once, that only the shock of it could teach us what it really meant. Others say that shock scarred more than it saved. But the world didn't stop with that first use. It imagined more. Science fiction writers, philosophers, game designers, artists. They all stared into the nuclear glow and began to build alternate worlds. What if? What if every city had a reactor in its heart? What if the Cold War had turned hot? What if time had split, and somewhere in a parallel timeline the missiles were launched? The idea of alternate history became a genre of its own. Books like The Man in the High Castle, where World War II ended differently. Films like Threads, which traced the days and years after a nuclear strike in haunting detail. Games like Fallout, which imagined a retro-futuristic world frozen in nuclear paranoia. And beyond the fiction, real questions. What if a missile is launched by mistake? It's happened before, almost. A flock of geese mistaken for an incoming strike, a radar glitch in the Arctic, a drill tape played by accident. In each case, a human being had to decide, is this real? Each time the answer was no. But what if someday someone hesitates a second too long, or not at all? We've built systems, yes, codes and protocols and safeguards, but they are operated by people, tired people, afraid people, people with seconds to decide, and in those seconds, the world can end. But let's imagine a different path. What if the bomb becomes obsolete? Not through treaty, not through force, but through innovation. Imagine we develop clean, safe, small-scale fusion, not for war, for warmth, for power plants, homes, spacecraft. Imagine the same science that built the bomb, lighting villages, hospitals, schools. In that world, atoms become healing. The glow no longer comes from detonation, but illumination. It's not impossible. The quest for fusion, real fusion, is still alive. Reactors like ITER in France or smaller startups experimenting with magnetic confinement, laser ignition, or even inertial fusion. It's difficult, expensive, but possible. And if it happens, maybe the bomb will become a relic, still feared, still remembered, but no longer relevant. That would be a strange twist, wouldn't it? That our most terrifying invention might give rise to our most generous one. Or imagine this. What if the bomb never stops? What if one is used tomorrow or next year, and the chain reaction isn't nuclear but geopolitical? A bomb dropped, a city gone, a retaliation launched, and then? Does the world survive? Do we pull back? Or does escalation spiral until there's nothing left to argue about? This is the scenario that strategists try to model, that governments pretend is impossible while quietly preparing for it. And in fiction, it's played out 1,000 times. Cities crumbling, satellites burning, survivors in bunkers, coughing under yellow skies. But there's a quieter what if. One that doesn't involve war at all. What if the bomb is used in space? It almost has been. In the 1960s, the US tested nuclear weapons in orbit, Operation Starfish Prime. They detonated a 1.4 megaton bomb 250 miles above the Earth. The result? A glowing sky. Damaged satellites. EMPs that knocked out communications in Hawaii. A reminder, the bomb doesn't need gravity. Or a battlefield. It works anywhere, even among the stars. Which leads to another strange idea. Could we ever use nuclear explosions constructively? Some scientists proposed using them to carve canals, build harbours, launch spacecraft. It was called Project Plowshare, swords into plowshares. One plan even imagined detonating bombs underground to mine resources more efficiently. Another, Project Orion, imagined propelling a spaceship through the solar system, using a series of small nuclear blasts behind a massive pusher plate. Imagine a spacecraft leaping between planets, riding explosions like stepping stones. It sounds absurd, but it was serious, funded, designed, feasible, and who knows? One day, if we ever leave Earth for good, maybe the same force that nearly ended us will help carry us beyond the stars. But here's a darker what if. What if the real danger isn't the bomb at all? What if the science it unlocked, the ability to manipulate atoms, to edit DNA, to simulate the universe, outpaces our capacity to wield it? What if AI designs better bombs? What if automation makes decisions faster than humans can intervene? What if we lose the ability to understand our own weapons? In that future, the bomb is no longer in human hands. It's in systems, codes, networks, and that's a deeper fear, not malice, but mistake, not evil, but error. Still, not all what-ifs are dystopian. Let's imagine one more, a version of the world where every nuclear weapon has been dismantled. No fanfare, no dramatic speeches, just a quiet dismantling, warheads diffused, materials repurposed, silos sealed. What would we do with the silence? What would a world without the bomb feel like? Would it be lighter, or would we worry about what might come next? Because sometimes fear is familiar, and peace can feel like an empty room. But maybe that room is where new stories begin. Stories about trust, about rebuilding, about science used without shadows. We can't unknow what we know, We can't pretend the 20th century didn't happen, but we can imagine. And imagination, for all its softness, is powerful. It's how we design, how we plan, how we warn, but it's also how we hope. And so, in the quiet space of night, between dreams and dawn, we ask, what if we get this right? What if we are the generation that doesn't flinch but chooses? What if the next use of nuclear science isn't a bomb, but a cure? What if we've already seen the worst? What if the countdown has been stopped, not with a bang, but with a whisper? So now we return. Not to the beginning exactly, but to the stillness beneath it. To that soft voice that first asked, why are nuclear bombs so destructive? And now, after all the science, all the history, all the wonder and fear and paradox, we might be tempted to offer an answer, because we can measure it now. We can draw the blast radius, name the isotopes, trace the fallout, chart the decay. We've talked about chain reactions and prompt neutrons and implosion lenses and kilotons and fusion cores. We've seen the mushroom cloud rise over cities and deserts and oceans of memory. And yet, it's still a question we feel more than we explain. The destructiveness of the bomb is not just in its physics, it's in its symbolism, its silence, the way it interrupts everything, thought, conversation, life itself. Because when we speak of nuclear destruction, we're not just talking about structures, we're talking about meaning, the sudden erasure of stories, of faces, of futures that never get to happen. That's what makes it different. Not just the fire, but the finality. Not just what it does, but what it unmakes. And in that space, in that pause after the flash, a strange clarity forms. Because the bomb doesn't just destroy buildings, it distills truth. That life is fragile, that science is powerful, that knowledge, once found, can never be unfound. And yet the bomb does not demand despair, it demands attention, and maybe humility. Because what we've seen across this journey is not just destruction, it's complexity, it's contradiction. It's the idea that something so small, a neutron, a uranium nucleus, can change the fate of cities. That a few atoms split in just the right way can release energy greater than all the wars that came before, and that the same hands that lit that fire also write lullabies, bake bread, plant seeds, whisper goodnight. How strange we are, how beautiful and bewildering and impossible. But that too is part of the answer. The bomb is so destructive because we made it, because we used our finest minds not just to look inward, but to open the atom, to peel back the skin of the universe and touch the fire inside. And when we did, it changed us. The 20th century split, just like the atom. There was a before, there is an after, we live in the after. But what we've also seen, through this long exploration, is that the bomb, for all its horror, is not the final chapter. It is a mirror, one we still gaze into, one that still asks us, what now? Because now, we know. Now we've seen. We've walked the ruins, read the reports, heard the silence. Now the choice is ours. And maybe, after all these decades, it still is. Maybe we're not too late. Maybe the knowledge we feared was too heavy can still be carried wisely. Because science is not a direction. It's a lens. It doesn't tell us what to do. It shows us what can be done. The ethics, the meaning, the path, that's ours to decide. So maybe this moment, quiet, late, gentle, is where we decide not with declarations, but with attention, with small acts, with remembering, with the decision not to forget how fragile this all is, how rare, how completely impossible it is that we are here at all, like breathing, listening, dreaming, with stars above and atoms within. And that brings us strangely full circle. Because when we began, we asked not just how nuclear bombs work, but why they matter. And now we see. They matter because they contain every contradiction we carry. They are power and fragility, knowledge and fear, hope and destruction, proof that we can do more than we understand, and still choose understanding. They matter because they remind us that intelligence alone is not enough. We must pair it with care, with curiosity, with kindness, even in the shadow of ash. And that maybe, just maybe, our greatest task now is not to build better bombs, but to build better stories. Stories that remember, stories that teach, stories that ask, what is worth protecting? And maybe that's the quiet miracle of this whole topic, that even in its fire, it offers stillness, a chance to pause, to breathe, to think slowly in a world that moves too fast, to say, I see, I understand, and I choose differently. That's the power science gives us, not just the tools, but the view. It shows us the fragile mechanisms behind the thunder, the pattern behind the flash, the mathematics behind the fireball. It says, look deeper, and when we do, we find not just destruction, we find ourselves, tiny, brilliant, terrified, awake, and now maybe we're ready to sleep. Because all of this, the history, the horror, the invention, the awe, can rest now, if only for a night. Not forgotten, but held gently, like a glowing ember, not to burn, but to remember, to keep warm the stories of those who saw the light, to honour the silence that followed, to carry the knowledge with care and rest in the truth that we are not defined by what we can destroy, but by what we choose to protect. So maybe, just maybe, the bomb isn't the end. Maybe it's a turning, a mirror, a lesson, a breath, and in that breath, the beginning of something else. So, where are you now? What time is it? Where you are? Is it still night? Or has morning begun to bloom at the edges of the sky? Has the room around you changed, cooled, dimmed, softened, while we've drifted together through atoms and echoes, cities and silence? We've been many places, you and I. We've wandered through deserts where fire was born, through laboratories where quiet thoughts became thunder, through fears we rarely name and futures we haven't yet written. And maybe now we can rest. Because the story of the bomb isn't really about endings, it's about attention. It asks us to notice what power feels like, what choices carry, what stillness means when it follows great noise, and you've noticed, you've listened. That matters more than you know. So if this gave you even a moment of calm, a breath that slowed, a thought that softened, a fear that untangled, thank you. Thank you for sharing this time, in this space, with this voice. Thank you for trusting that science can be gentle, that curiosity can be a lullaby, that wonder isn't always loud. Sometimes it hums like cooling metal or a heartbeat in the dark. If this soothed you, you're welcome to stay, to return, to bring someone else. This space was made for people like you, thoughtful, restless, dreaming. People who ask big questions late at night and don't need every answer to fall asleep. So now, if your eyes are heavy, let them close. If your thoughts are full, let them quiet. If the world feels too vast to hold, set it down for a while. The atoms will still be there in the morning, and maybe, just maybe, so will the light. Sleep well, fellow traveller, wherever and whenever you are.